is equal to velocity multiplied by time. Right, and how I did that, let me just show you right now. We can consider a triangle. Right, and we fill in the triangle based on our formula here. So we put velocity here, and we say that velocity is equal to displacement, so we put displacement here over time. So whichever quantity we were trying to find, we simply cover that quantity, and then we will be able to determine the formula for that quantity. So in this case, when we're trying to find displacement, we simply would cover displacement, and we will see that displacement is equal to velocity multiplied by time. So working this out, our velocity again is 9 meters per second, and time is 5 seconds. So whenever we work this out, 9 times 5 is 45, and this is in meters. So our displacement after 5 seconds would be 45 meters. So let's continue. We're going to look at part 4. Alright, so in part 4, we're asked to find the work done by the force. So let me just write work done. Okay, so if you can remember, our formula for work is work is equal to force multiplied by distance moved in the direction of the force. So we write work is equal to force times distance. So once we know the force and we know our distance, or in this case displacement, because the object was at a particular point, let's say at point A, that's our object at point A, the experience is an acceleration by some force and move some distance, and now is at point B. So we're going to take into consideration the distance, or how far out of its original position the object is, and we consider that to be the displacement from that starting point. So we can use our formula here. So we say work is equal to force times distance. So again, from earlier, we can recall that the force was, this is our force here. So force is 0.0045 newtons multiplied by 45 meters. Right, so let me call on the service of our calculator. So we have 0.0045 multiplied by 45, and we'll get an answer for 0.203. Right, we just round up on this second 2 here to 3 because of the 5 here. So 0.0203, and you will remember that the SI unit for work is the joule. Right. So our work done by the force now is 0.203 joules. Now the last part in the question wants us to find the power dissipated by the source of energy. So let me work that right now. Alright, so let's say part 5 wants us to find the power dissipated. Okay, so power, mechanical power, let's call that P, is equal to work done over the time taken to complete that work. So our formula then now is equal to P is equal to W over T. Now we just found work, right? And we said that work is 0.203 joules. And the question wants us to find out the power dissipated by the source of energy. Now the force, or the object, experienced the acceleration for 5 seconds. So we can say then that the force was acting for a period of 5 seconds. So our T then is equal to 5 seconds. Right? So we can plug in these values and solve for our power. So work again is 0.203 joules and our time is 5 seconds. So getting out our calculator again, we can say 0.203 divided by 5 gives us an answer of 0.041 joule per second, or 0.041 watt. Right, so this was Junior Roberts with realjuniorroberts.com. If there was anything in this question that you wish to get further clarification on, please post them below in comments. Send me an email and I'll do my best to clear up any misconception for you. Please share this if it was helpful and you think it might be helpful to someone. Like, share, subscribe, and hit the bell notification to get further updates on new videos when I post them. Thank you for watching.